So we're going to be talking about lesson 1, 3, 2 in this video. And so the things we need to remember from lesson 1, 3, 1 is we learned properties of supplementary angles and straight angles, and we showed that vertical angles were congruent. Today we're going to figure out about some more other angle pair relationships. So Marcos was walking home after school when he noticed a pattern of parallelogram tiles on the wall of a building. So this is the pattern he's noticing. And one thing to keep in mind, at the beginning of Marcos's diagram is shown to the left. This type of patterning is called a tiling or a tessellation, in which a figure is copied and translated to fill an entire page without gaps or overlaps. So we do this with tiles on the floor, but like if you're actually using physical tiles. We also do this in other ways. So this is a very common technique used in construction and other things. So what we're trying to do then is a rigid transformation that can carry one parallelogram to another. So if we take a look at this parallelogram here, how could we move it so it was now here? So what could we do? So what we could do is we could translate down and right. We could also talk about moving this one to the green space. If I was moving this one, I would move up and left. So for the first one, down and right is what I'm doing. And we can't be more specific here because we don't have any ways to be specific. But we could also reflect straight across and it would be there. So there's other ways to think about it, but translating is the easiest way. And with a tessellation, you're really only translating. Consider the angles inside a single parallelogram. So we're just going to look at one of the parallelograms. And so I'm going to trace one. Pretend I did a better job. I can just kind of move it. Okay. So which angles are congruent and how can we prove it? So the two acute angles in this parallelogram are congruent, and the two obtuse angles are also congruent. How can we prove that? Well, when we were talking about in lesson 111, when we were doing the Venn diagrams and we were putting all the shapes in and we were able to put the parallelogram in 180-degree rotational symmetry. So what I'm going to do is I'm going to go ahead and take this picture, duplicate it, not like that, and go ahead and try. Now remember, my corners aren't sharp because I wasn't very careful in my trace, but I'm going to go ahead and try to turn it around 180 degrees and then move it onto the other, just so that we can tell I did that. I'm going to make it green. And so even with my crude drawing, you can see that it fits perfectly. And so if it was drawn better, it would be a perfect fit. We can go back here and it looks like I just traced it straight off. And so that's how we can prove it. Because when I rotated it, this funky little turned angle ended up right there. So let's just show that again. See how I have this one not very smooth angle right here? When I've turned it around 180, you can tell that it's 180 because everything's on the bottom now instead of on the top. And see how that funky curve is now matching up with that one, and the other two are matching up with each other. And that's how we can prove it. We can prove it by rotating 180 degrees onto itself because it has rotational symmetry. Now that's not a very careful proof, but it didn't say proof, it said justify. So that's my justification. Because of rotational symmetry, those angles are congruent. Since each parallelogram is a translation, what can be said about the rest of them? So what's cool about this pattern is that since they're all tessellations, I didn't mean to do that. Since they're all tessellations, they're all congruent parallelograms, which means all the obtuse angles in the whole picture are the same angle. Miss that one, miss that one, miss that one. So they're all the same angle. And so if you had this picture, we would color them in. I'm going to go ahead and use a highlighter. So if you could try to sketch that picture, that'd be really helpful, but we do what we can do. So highlight this angle, this angle, this angle, this angle, this angle, this angle, that 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 angle. And if you recall, we talked about vertical angles and see how these two are vertical to each other. And I missed that one. That was vertical, vertical, vertical. So that's cool. That's a pretty reasonable explanation, is that those are vertical angles, and that works out. And so, neat. What about the other angles? So switching my color of my highlighter, we have this angle, that angle, this angle, this angle, this angle, this angle, that angle, this angle, this angle, this angle, this angle, this angle, this angle. And you can see, if we look closely just at the red dots, that these two are vertical angles. I don't know that I got very many vertical angles in. I think that's the only two. But that same thing would apply here. And so what's really cool is what's happening with everything. So we've got lots of congruent angles and lots of other things. And I missed one red angle. Back to the highlighter, I missed that one. Okay, so anyway. So basically, that's really interesting. We've got lots of pairs up. So so all the acute angles are congruent and all the obtuse angles are congruent. So I'm going to write that down. All acute angles in picture and all obtuse angles in picture. And this, by the way, is how you write an ampersand by hand. What about the relationship between the lines? So when we think about the lines themselves in that picture, can we find any that must be parallel? Well, since this is a parallelogram, this line and this line have to be parallel. And we can extend that. Those lines have to be parallel. Okay. So we're going to go ahead and actually grab that picture. Okay, so I've taken that picture and put it here. Relationships between lines. So I'm going to color these lines here, including this one and that one. And those are all parallel to each other. So I'm putting one arrow on all of them because they're parallelogram sides. So of course they're parallel. Then I have this line, and this line, and this line, and this line that are also parallel to each other. Because again, the sides of the parallelogram. And so that's pretty cool. Okay, so all of the horizontal lines, because the purple ones are horizontal, and all of these diagonal lines in this picture are parallel. So if you wanted to draw just yourself a picture really fast, I sort of matched it. And so you notice this is not well drawn, but that's the idea, is that we have all of these sides that are parallel and stuff. That's pretty neat. Okay. So Julia wants to learn more about the angles in Marcus's diagram and has decided to focus on just a part of his tiling. So here's his tiling, and she's basically kind of see this box right here. She's zoomed in, and that's what she's focusing on. Okay. Okay, so we need some vocabulary words. Right here it says, in Julia's diagram, which line is the transversal? And so right here in this box, it says a line that crosses two or more other lines is called a transversal. So a transversal is just a line that crosses other lines. It's just a fancy name. And which lines are parallel? So in this, again, she's just focusing on this piece of her drawing. Okay, so the line that is a transversal is this one. JK is what we would call that, because those are the letters on it that are not little. The the lowercase letters are referring to the angles, and the uppercase letters are referring to the line. So this is a transversal. Okay, and which lines are parallel? That would be LM is parallel to NP. And that's the symbol for parallel there. Two straight lines. Okay. So it says to trace on tracing paper. I don't have tracing paper available to me digitally. So I'm going to go ahead and trace with my pen and just draw it. Let's make it green. And so trace angle X. So, and then move it along the transversal until it lands on top of another angle that matches it. So I'm moving it along the transversal. Oh, hey, look, B. B is the same. So that's B, and we use this word correspond. What is the relationship between angles B and X? Angle X and angle B have equal measures, and they are congruent. We know that because I can transform one onto the other. Angle X and B are called corresponding angles. You should be writing this down if you're not using a note guide. Corresponding angles, because they are in the same position. Because I didn't have to rotate or reflect. I just, all I did was shift. Another pair of corresponding angles would be D and Z, along with A and W and C and X. So just kind of keep that in mind. I'm going to go ahead and mark the two we were talking about, X and B. Those are the two corresponding angles that I have in this picture. Okay, I know that they're congruent because I can translate, so I should write that down. Since I can use a congruent because I can translate angle X onto angle B. Okay. All right, moving on. The corresponding angles in a diagram are congruent because they were formed by translating. The parallelogram. Name all of the other pairs corresponding in Julia's diagram that are also congruent. So here's Julia's diagram. Let me stick it behind so that it's not in the way of the words. So there's Julia's diagram. We're going to name all the corresponding angles. And I did that in just a minute ago, but we'll do it again. So we have angle B, and I'm just going to write congruent between the ones that are congruent, angle B and angle X. We have angle D and angle Z. My congruent sign is terrible. I'm going to switch colors now. Angle, so that's the two on this side. We have angle A with angle W and angle C with angle Y. So if D is equal to 60 degrees, what can we find all the other angles in the whole picture? So notice that B is 60. Okay. We know that C has to be 60 because they're vertical angles. Okay. So C equals 60 vertical angles. Okay. What else do I know? Well, B and X are equal. We just said that a minute ago, so that's 60. Y is 60 because vertical angles again. So angle X equals 60. That one's corresponding angles. And then angle Y is 60, and that's vertical angles. Or you could have done corresponding angles with C. So you could have used either reason. Now this is where it gets a little bit trickier, but not hard. I wouldn't call it hard, just trickier. Can I figure out angle A? So look at angle A and C. So let me just take A and C and kind of draw them on another picture. So C would be, what? How about A and B? Look at A and B. That's easier to draw. A, B, right? Tell me about angles A and B. Well, A and B form a line, right? So A and B form a line. And so what's the relationship between A and B? Well, they add up to 180. Which means A must be 120. Because A has to be 120 so that it will add to 180 with D. Okay? So that's how we figured out A. We knew it was supplementary to B. Okay. And so once we know A, D is 120. Vertical angles. I'm going to go with VA for that because I'm running out of room. Z is 120, corresponding angles. And W is 120, vertical angles. So I found them all. All of the measures in the whole picture. Isn't that crazy? Just with knowing one, I can find everything. It's pretty awesome. Okay, and that should have been F. I don't know why the numbering got switched up there. I'll change it so on your guide it's not. Okay. So, are they always congruent? So, if you have enough information to determine the other angles. So, 135, what we know is these two lines are marked as parallel. Okay. Since they're parallel, these two angles correspond. So X equals 135. And this angle Y is a vertical angle with X, so Y equals 135. So corresponding and vertical. In picture B, nothing's parallel because there are no angle marks on any picture. So since nothing's parallel, I can't find X. Because it's way over here. I can't do anything about finding X because nothing is parallel. But I can find Y. Because X and Y, 135 and Y are a line. So Y equals 180, take away 135, which is 45 degrees. Okay. And that would be because they're supplementary or linear pair. Let's use linear pair. You learned linear pair. Okay. All right, moving on. What about these? Can we find these? So I want you to go ahead and try these two. Pause the video right now and try these two, and then I'll be back with the answer in just a minute. And so in picture C, I can find both of them. X is 135 because they're parallel lines, and Y is 45 because it's a linear pair with X. In D, I cannot find Y because there are no parallel lines, but X is 45 because it's a linear pair with 135. And so that is what we're talking about today. Oh wait, there's more. Just kidding. All right. So let's see if we can do something else. So in this diagram, see if we can figure out x. So what we know is that we have parallel lines. So, and there's arrows, which means the lines do extend all the way out. Now, I'm not drawing them very good, but they extend forever, so that's important. So this angle right here must be 65. So these two can add up to 180. Is there a linear pair? Now, if that's 65, then this angle is also 65. Let me change colors. This angle is also 65 because they're corresponding. Which means that this angle is also 65 because it corresponds with the red one. No for other word angles. Okay. All right. And there's two more for you to try. And again, pause the video and see what you can come up with. C's a little tricky because you've got a relationship to find x. You have to actually set up an equation. So try B. I'll be back with an answer. So since these two are parallel, that's cool. That makes me very happy. But this line right here, this slanted transversal, because it cuts through two other lines, is not parallel to anything attached to 53. So like I can't assume anything about this angle, and therefore I can't figure out that one. I can figure out this one, but there's no relationship with that one. So I don't have enough information. It's too bad. All right, let's see what we can do with C. So I'll get you started. We've got all parallel. C, parallel, 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 parallel. Lots of parallel. Parallel makes me happy. So these two are parallel, and these two are parallel. Like those are the same two. Just kidding. These two are parallel. Okay, so those are parallel, those are parallel, those are parallel. Awesome. Yay. Parallel lines makes me very happy. So, since they're parallel, we know that eventually all the pairs of angles could be the same. So this one's a vertical angle, yes, with that one. So those are the same. This one corresponds with that one, with this one. So that's the same. This one, corresponds with this one. So that's the same. Oh, so that means this thing is the same as that thing? Cool. Let's get rid of some of my writing. So those two are the same. Neat. So since they're the same, I can set up a simple equation. I can say 4x minus 25 equals 3x plus 10. Go ahead and solve that and see what you can come up with for x. I chose not to show my work for solving for x. X is 35. So there you go. So good luck with everything. I hope you enjoy the work that we have to do as we continue forward.